Okay, here we go. This is porosity. This is page 12, top of page 12. So please pause it and copy this down, please. Okay, porosity, amount of empty space in the soil. So now this is not stuff going through, this is storing. Okay, so we have smaller, medium, larger size sediments in this beaker, water filled up to the top. Now my question I would always ask students in classes, which can hold more water? Or which is holding more water, A, B, or C? Think about that for a second. Get an answer in your brain. I'll walk over here. Okay, I'm back. All right, some people said A, some people said C. Maybe not a lot of people said B. Want to know the answer? Yes, you do. I know you're dying to hear the answer. I'll tell you. Trick question, the same. Porosity is the same. As long as this is all really well sorted, they're all the same size and really round. These are all the same size in here as each other, really round. Same thing here, is the same porosity. Hard to wrap your brain around it. You may not really see it or notice it. Okay, but please pause this and write this down. Okay, how much water sediment can hold is another good way to say porosity. And porosity of A, B, and C is the same as long as the sediment in each beaker is very rounded and sorted. And by sorted, for our definition now, means all the same size within the beaker. All of A is the same exact size. Everything in B is the same size. That is key. Know that, learn it, know it. That's the one kids always get wrong. Test quizzes, they get it wrong because they don't take it seriously and learn it and know it. It's not about common sense. It's not that. You got to kind of know it. It does not jump out at you. It makes sense to you that the permeability, water will flow faster through here if I had a hole in the bottom. Flow faster through big ones, slower through that ones. That makes sense to people. This is not that thing. Okay. Other things that affect porosity, let's just do this. Let's write this down. Please pause this, copy it down now. Okay. Things that affect porosity is the shape. Rounded versus angular. The white is the empty space. That's where the water will be stored. If this is underground, think about underground, which will store more water underground. What kind of soil do you want under your ground to store water? And rounded particles are going to store more. Look at all the blank space here. The angular ones have more flat space, so they fit together a little tighter with all the gravity and weight pushing down, so less porosity here. So the graph is going to look like this. Know these graphs. We have a lot of graph stuff on here. It's knowing the idea and seeing how it goes in a graph. Packing. Loosely packed can hold more. This is higher porosity, loosely packed. This is more packed. So if you want to have high porosity in the field, let's say, you don't want a lot of trucks driving on it over and over to pack it down. It's like negative for the affecting the porosity. And then that's the graph here. Okay, please pause, copy this down, go. Okay, sorting. Well-sorted particles have more porosity than unsorted. So this is going to can store more water, higher porosity, and less. The smaller ones all end up fitting in between the spaces of the larger ones. Very little open space here, much more here. You can visually see it, so that kind of makes sense to people. The porosity, unsorted versus well-sorted, that's what that graph will look like. I'm going to pause it here, or stop it here for now.